Okay, so mopping up the first of statistics. Range gives us an idea of the overall spread of the data. Bigger the number, bigger the spread of the data. Okay? To work it out, you get to match the number and you take away the minimum number. So the highest number, take away the lowest number. We've done that in grade 7. It gives you an idea of the overall spread. Interquartile range is a better form of range. Okay? To work it out, you just take whatever your Q3 was, take away Q1. And that gives you an idea of what the spread of the middle 50% of the data is. Remember, Q3 to Q1 is the middle 50%. So it's better because it doesn't take into account outliers. Okay, you can have those ridiculously high numbers that aren't anything like the data. Okay, this one will range. Okay, will take into account those, and you'll get a skewed idea of what the spread of the data is. Here, interquartile range gives you an idea of where most of that data is. Now, an outlier, okay, is a value that is significantly different to the rest, and significantly actually has a mathematical definition of 1.5 interquartile range away from Q3 or Q1. So you go at Q3, okay? Say you're at Q3. An outlier is going to be anything that is over 1.5 IQR above Q3. Okay? So say your IQR was 2. Okay? 1.5 times 2 is 3. Okay? That means that anything that is over 3 away from Q3 is considered an outlier. Okay? And you can justifiably not include that in the data. Okay? But it has to be a pretty good justification. Say at one point you can explain why it's abnormal. Okay? You can also say it's an outlier, so it's going to skew everything else. You can move that benefit from the data. We're going to do an example on that. And last of all, standard deviation is a summary statistic. Okay, so it's another number that tells us about the data, and it tells us how spread out the numbers are. But it tells it in a different way. It shows the variation from the mean. Okay, and it gives you an idea of what a normal value is. Okay, within and normal value is within one standard deviation of the mean. So to show that, what I'm going to do is go to here. This is it. This one. Okay, this website here, and they've got an awesome example of what standard deviation actually means. So say this person went and measured the heights of, to the back of certain dogs. Okay, we've got big dog, small dog. Okay, now find the mean. That's the mean, the yellow line there. Okay, then go and actually work out how far away, whether it's minus 224 or positive 76 away each dog is from the mean. Okay, do some maths, which in this case is squaring all of those numbers added together, divided by the mean. And then you find that the standard deviation is 147. Okay, that means we could say that a normal, in this regards, taking into account all of these dogs, the normal dog is going to be within one standard deviation of the mean. Okay, so we're going to be within 147 mil of the mean up or down. And anything that's outside of that range, is maybe not considered a normal dog. It's a big dog or a small dog. Okay. Now it's slightly different to an outlier. Okay. Where an outlier you use interquartile range to work it out. this one uses standard deviation, but these wouldn't be considered outliers. Okay? Because this calculation uses the mean to solve it. Okay? And remember, mean takes into account all numbers, so we'll take into account n. It's not a good idea to use the standard deviation to work out what an outlier is. That's why we use the interval range. Okay? So, going back to our one here, okay? Each quartile range is used to work out outliers. Okay, remember anything that's 1.5 away, over 1.5 away is an outlier. Standard deviation, okay, just gives us another summary of saying what's normal. Okay, so let's have a look at that in terms of, there are two standard deviations. Okay, there's one that looks like, so there's one standard deviation that looks like this. Okay, this is sigma and x, so of your first list. Okay, that is if you are working out the standard deviation of a population. Okay, so everyone is in your data. If you're working out a sample, say in this class I only surveyed 10 people, okay, and I got their scores and I worked out standard deviation, they need to do a different one, okay, which looks like this, SS, okay, which stands for a sample. So if you're not sampling, if you're not taking everyone into account, you're just working out a sample. You can see if I put the 5 months, the one bar here, we've got the 2. Okay, so this here is your population standard deviation. Okay, say for example we took everything into it, if we had data for everyone, okay, you would use that one. If you had data for a small sample and you wanted to go, say, use that as a sample for everyone, use this one. Okay, now, example. Okay, example's going to clear things up a bit. So, here's some temperatures. Okay, here in Fahrenheit. Let's work out the range. Okay, range equals mass take in. Okay, which is a maximum of 300. Our min is 69. Okay, which means that our range is going to be 239. Okay? So that's our range. Easy. Each quartile range is, okay, IQR equals Q3 take Q1. Same maths, you just have to know what Q3 Q1 is. So to do that, back to your calculator, chuck the data into this one, and then 1 bar. Now remember, set tells you what 1 bar is working off, so make sure it's this one. Okay, and then we go down and we find out what Q3 and Q1 was. So Q3 is 71.5 and Q1 is 70. Okay, so 71.5 take away 70, which gives us an interquartile range of 1.5, big difference. Okay, so we know that this one, okay, takes into account outliers. So that 300 degrees that's in there, okay, is going to skew our range. We can see that most of the data is pretty close together. So the interquartile range is a better, okay, way of representing because it doesn't take into account outliers. Okay? No outliers. Now, let's actually see if we've got any outliers. Okay? Remember I said that an outlier is something that is 1.5 away from, over 1.5 away from Q3 or Q1. Okay? Here is our interquartile range. Okay, so we go 1.5 is our interquartile range, and we're trying to find out what 1.5 away is, so we need to know what that is. Okay? That's a coincidence that they're the same number. That is that. This is just, okay, finding out what 1.5 away is. So 1.5 times 1.5, when we go to this guy, okay, so we'll come to the 1.5, 1.5 equals 2.25. So, anything that is over 2.25 away from Q3 or from Q1 on the bottom side is an outlier. Okay, so that means, okay, anything that is, what was Q1? 70. Anything that is 70, take 2.25, which is going to be 67.75. Anything that is below 67.75 would be considered an outlier. And for Q3, okay, we have, what was our Q3? 71.5? Okay, plus 2.25 is going to give us 73.75. Anything that is over, okay, 73.75 is an outlier. So, is there anything below 67.75? No. Is there anything above 73.75? Yeah, this guy. Okay, so we would say that, okay, 300 degrees Fahrenheit is an outlier. Okay, and here's the thing with outliers, they don't go on box plots. Okay, well, actually, I lied. You plot them, okay, but they're not the maximum. So you put the point down, but you don't actually make the whisker go all the way out. And we're going to draw that down the bottom. Okay? Last thing, standard deviation. Okay? We're going to assume that this is a population, so we have all of the numbers. So we're going to use this one. Okay? And we'll just read it off the back over. Okay? Here we go. Menu, stat, calc, 1 bar, this guy here, 63.427. Okay, so standard deviation is 63.427. Okay, that gives us an idea of how far away most of the data is from the mean. Smaller the number, the closer things are to the mean. Bigger the number, further away from the mean. So, what we're going to do is we're going to do a box plot. Okay, here to show that an outlier doesn't go on. Okay, obviously, we're going to use a ruler. I'm going to use a ruler this time, even. Okay? Oh, I won't. Yeah. There we go. Now, we've got, I need to get a pen. Okay, what's our value? So we're going to go down to 69, so we'll make this 65. Okay, we'll go up in ones. No, we won't go up in ones. We need to go up in 3. It's going to be horrible. In 2s, all the way up to 300. So, what we do is we go up in ones. Okay, 65, 66. What's the highest we have to get to? 300. So, apart from that.
71, 70, no, 73. Oh, 73. Oh, 73.
73?
Yeah.
Alright, I'll do 73. Okay, so here we go. We're using a ruler this time. So, minimum 69. Okay, it's here. What was that? Now, Q1 was 70. Q median. Okay, we didn't actually get the median, but we're going to look at it now. Median was 70.5. Okay, 70.5. Okay, Q3 71.5. 71.5, and then